And now we discuss the power. So we have the power. So the power is defined by, so the power, so this is the symbol P, it is defined by the work done per unit time. So we have the work done per unit time. So we talked about the work done, and now, so the power is defined as the work done. So how much work is done per unit time? If we have more work done per unit time, we will have more power. If we have the same amount of work is done per longer amount of time, then the power it will be small. So the unit of the work done is joule. So we have the joule, and then it's represented by J. So, and the time is represented in seconds, and for the power we use unit watt, which is represented by W, big W. And now, so the power is at the rate at which the energy is transferred either from one form to the other form, or to the other objects, for example. Example is, for example, we have a 100-watt light bulb. So bulb. So we can say, since this is the 100 watt, so this is the watt, and then we can also write it in the form of joule per second. So that would mean that it's 100 joule per second. What does it mean? It means that, so the 100-watt light bulb is transferring the electrical energy, 100 joule electrical energy per second. So every second this 100-watt light bulb is transferring 100 joule energy to it's converting this electrical energy to light and also some small amount of heat. So that's what the electric bulb are also hot. So this is what it means. Similarly, if we have, for example, 500-watt motor. So motor, we can also write it as 500 joule per second. So it means that this motor is 500-watt motor is transferring or converting electrical energy, 500 joule electrical energy into mechanical energy. So it can either pump water or it can also do some other things, but in general we can say that the 500-watt motor is transferring or converting 500 joule electrical energy into mechanical energy in every second, per 1 second. So this is the definition of work done. So the definition of the work done, the power actually. So this is the work done per unit time. And this is, we know from the real life examples. For example, we have the 100-watt light bulb, which is very common. And right now we have the LEDs, for example. So we can use the same example for the LEDs. The LEDs are usually 25 watt or 20 watt. So it's transferring 20 watt electrical energy to light every second. So it can be, it is actually transferring one form of energy to the other form in this case. Now we discuss one example. So we have example. Example is that we have two people. So we have two people. We have one person here. So this is, we call this A. So the name of this person is A. And then we have the second person. Say So we have the B. So we have two people and they are lifting 50 kgs of, this is one block here. We have another 50 kg block. So this is, we have two blocks. So these two people lift this 50 kgs of block to 2 meters. So we have 2 meters. 2 meters, same. So 2 meters. So these two people have done a same amount of work. So why? Because we have the same mass. So the same mass would mean that the gravitational force will be the same because we have the mg. So we have the same mass and they have lifted this to 2 meters. So they have worked, they have done the same amount of work. So first we will calculate how much work is done by these two people, who is, one is A and the second person is B. And then we will calculate how much work, it's how much power is done by the two people. Which one has done more power? So for the power, we also need the time, for example. So this person has done this in 10 seconds and this person has done it in 1 second. So delta T is 1 second. And now we calculate the work done, for example, first. So we have the force here and then we have the mg. So the mg is the gravitational force. So we just replace this F by mg and then we write the distance. Displacement is 2 meters. So we have the mass is 50 kgs. We have the gravitational acceleration, which is 9.8 meters per second squared. And then we have the displacement here. So when we put all these values, so we will get 980 joule work done. So this work done is done, so the work done is the same for this person A and also person B. And now we want to know how much power is done by the both of people. So we have the work done per unit time. So we have the 980 joule. So per unit time, the time here is 10 seconds. 10 seconds. So we can say that it says 98 watt. So this person has 98 watt power, and now we will calculate the same thing for this one. So for the person B, so for the person A, so person B, we have the work done divided by time, and we know the work done is 980 joule. 980 joule divided by 1, because this person has lifted the 50 kg block in just 1 second. So the power for this person is 980. So what do we see here? So we see here that both people, the person A and the person B, has done the same amount of work. Why? Because we have the 550 kg mass here, 50 kg mass here. So the gravitational force for both person is the same, and the displacement was also the same, so 2 meters. So we calculated the work done, which was 980 joule for both persons. But since this person has done the same amount of work in 10 seconds and this person has done the same work in 1 second, so this person has less power because it took longer time, which is 10 times larger, 10 times more time than this person. So this person has more power than this person. And now we will solve one numerical problem here. So we have a 20 kilogram box is lifted to 200 meters above the ground in 5 minutes. We are asked to calculate the work done and also the power. So what is given? So we have 20 kilogram mass is given, and then it is lifted to 200 meter. So we have the D is given and also the time is given. So the time is given, so the time is 5 minutes. So we will convert this to seconds. So we are asked to calculate first the work done and the power. So how do we first we have to calculate the work done, because for the power we need the work done. So how do we calculate it? So we have the mass and we have the displacement. So we have, for example, this mass, which is 20 kg, is lifted to 200 meters in 5 seconds, 5 minutes actually. So 5 minutes. So for the work done, we need the force and we need the displacement. So we have the displacement, which is 200 meters, and then we have also the force, because we have the gravitational force. So we have the mass here, so we just multiply it with the gravitational acceleration, so we will get the force. So the work done is equal to the force multiplied by displacement, but here in this case we have the force is mg, and then we have the displacement. So if we put the 20 kgs here, and then the gravitational acceleration is 9.8 meters per second squared, and then the displacement is 200 meters. If we put all these values, we will get 39,200 joule. So we have calculated the work done for this system, and now we are also asked to calculate the power. So the power we know is the work done per unit time. So the work done we just calculated is 39,200 joule per 5 minutes. We have the 5 minutes, but we have to convert this to seconds, and we know that once 1 minute has 60 seconds. So if we convert this minutes to seconds, we have to multiply this with the 60. So if we calculate this thing, and then we will have 130.7 watt power. So this was the problem number 1. So we had the problem number 1, and now we have the problem 2. We solve another problem as well. So in this problem we are given, so if we are asked how long will it take for a motor of 2.5 kilowatts to lift 80 kilogram block to 230 meter height. So what is given? So we have the power is given, which is 2.5 kilowatts. Kilowatts means we have the 2500. So kilo means 1000 actually here. And we are also given the mass, which is 80. So this is 80. So this is the mass, and the displacement is 30 meters, and we want to know how long does it take. So we will calculate the time. So the problem actually is, first we need to understand the problem. So we have, for example, we have 80 kilogram block here, and this block is lifted by a motor to a height of 30 So this is 30 meters. So this block, this 80 kg block is lifted to 30 meters, and the power of that motor, the motor that is lifting, that lifted this 80 kg block, the power of that motor is 2.5 kilowatts. And we are asked that how much time that it took to lift this 80 kg block 2-3 meters with this given motor. Again, first we need to calculate the power. So the power is the force multiplied by the displacement. In this case, again, since it's going against the gravity, we will have the gravitational force, which is mass multiplied by the gravitational acceleration. So when we put these values, so we will get 23,520 joule. So this is the work. Done, and now we want to know what is the time. So we have for the time we have the formula of the power, but we are interested in the time because we have the power here. The power is given, and the time and the work done is we just calculated. So we can also write this here, which is power work done divided by power. So if we put these values, so the work done is 23,520 joule divided by the power. The power is 2500 watt. So the time that it will take is 9.4 seconds. So we just calculated the time that it will take. So now we want to know what is the relationship between the power and the velocity. Since velocity has a time, so the velocity is the distance or the displacement covered per unit time. So in a power, we also have both things. We have the displacement and time. So we want to know what is the relation between the velocity and the time. So the power and velocity. So the power we just discussed is the work done per unit time. So and we know that the work done can also be written as the force multiplied by displacement. So what we see here, we have the displacement per unit time. So we can write the force, and for this part here, for the displacement per unit time, we can write velocity. So the power is also equals to the force multiplied by the velocity. So we can also write the unit of the power is the force is the unit of the force is Newton, and then the velocity has a meters per second. So this is, we can also write, so the power and the velocity is related in this way. So we have the force multiplied by velocity is also giving us the power, and the unit is the Newton meters per second. So we will solve a related problem, numerical problem. So we have a problem. So we have a 70 kg man runs up along a flight of stairs in 4 seconds. The vertical height is 4 meters, so we are asked to calculate the power. So the problem is that we have some stairs and a person. Here we have this person, its mass is 70 kgs. So this person has a mass of 70 kgs and this person runs through the stairs in 4 seconds. So we have the time is 4 seconds and the height, the vertical height is 4.5 meters. So we have the mass of this person. So if we have the mass of the person, since it's going against the gravity, we will use the gravitational force. We have the displacement and we have the time. So we are asked to calculate the power. So the mass of this person is 70 kgs. G is 9.8 meters per second squared, and the height is, or the displacement here we can also write, is 4.5 meters, and the time is 4 seconds. 4 seconds. So we are asked to calculate the power. So the power is work done divided by time. So we can write that the force, so the power can be written as a force multiplied by the displacement per unit time. So we can write the force in this case is the gravitational force. So we have the displacement divided by time. So we have now here the mass, here we have the gravitational acceleration, and we also have the displacement, which is the height of the stairs, the vertical height, and we have the time. So if we put these values, we will get the 7.7 into 10 raised to the power 2 watt. So this is the power of this person when he was going upstairs.